Hello my dear students, welcome again. So in the last class we discussed about binary codes. There are different codes are there like BCD was there, ASCII code was there and so on. So for today's session I am here to deal with the binary logic, which is also very important in this digital logic and computer design. Okay, then basically this binary logic deals with the variables that take on two discrete values. Why? Because the binary name itself tells us that binary means two, so it works or it operates on two discrete values. Okay, you can say two discrete values. Here the discrete values in the sense only the binary number, as you know, which is 0 and 1, right? Okay, and what it means, the binary logic which deals with variables that take on two discrete values. Here the discrete values are 0 and 1. Okay, and with those operations that assume a logical meaning, if we operate anything based on these two discrete values, that should be uh, that should we have to assume that that is a logical meaning. The two values the variables assume may be called by different names. Say for example, if any operation is performed on these two discrete values, say 0 plus 1, I can write the result may be uh, treated by different names. Say for example, either result may be true, I write it T, result may be false, I write it as F. Okay, result may be true or false, right? Or you can call result may be high or low. Okay, result may be high or low, or you can say result may be 1 or 0. Okay, you can call like that also, result may be 1 or 0. Okay, this is how the binary logic actually works, right? Now the binary logic introduced in this section because, and which is equivalent to an algebra called Boolean algebra. Later we'll study about Boolean algebra, and just I introduced there is a concept called Boolean algebra. There we require this binary logic. Okay, okay, now you can see it deals with the binary variables that take two discrete values 0 and 1 with the logic operations. Okay, this is the main concept of binary logic. Three basic logic operations are and, or, not. Remember this. These are the main important basic operations in binary logic: and, or, not. Okay. Binary logic variables are typically represented as letters A, B, C, X, Y, Z, or anything you can take from alphabet letters. There are 26 letters are there. Among those you can take whatever may be the names for a variables. I think this is clear to you, right? Okay, then you see how this binary logic function will be. Okay, F means that is a function. Here you have written vars is nothing but variables. Okay, and you will get the equivalent expression. I write one expression right here, F which accepted as, okay, variables, say for example variable X, okay, and Y. Okay, and what I'll get the equivalent result here. Result is in the form of either it may be X plus Y, okay, X plus Y, or X dot Y, you can call like that. You will get a different kind of results which you used based on the operators. See here, variables in the sense set of binary variables. I told that vars in the sense set of binary variables. Variables may be yeah, whatever may be the names of variables you can take, right? Okay, and here constants are zeros and ones. Why these are the constants? I'm telling you, zeros and one, 0 or 1 is the constant because whatever may be the result you obtain, that is only in the form of 0 or in the form of 1. Okay, right. See one example here mentioned, a function f of a comma b is equals to a prime. This is called as prime, or you can call it as also bar, a bar dot b plus b bar. This is the example which we are given. Okay, when we are studying about Boolean algebra, there we study the complete function. Okay, you just remember this: a prime dot b plus b prime. This is the expression. This is called as expression. Okay, here three variable function is taken, that is g of x comma y comma z. Their expression is obtained that x dot y plus z prime, or you can call x dot y plus z bar. Okay, okay. And you see now some basic logical operators or logic operators you may call. As we told here, the operations which we shown here also, the three basic logic operators are and, or, not, and how these will be, we'll study right here. The first operator is known as and, right? And, or, not. And if we are dealing with the binary, here and is operated on two values. Okay, that is called as binary operator. Or is also operates on two or more values. This is also binary operator. And not is treated as unary operator, which operates on single variable. You remember this single variable. Okay, here some function is given. I don't want to explain this function. Later you will get to know how this function will be. Just you need to remember that and, or, not are the three basic logic operators. I will show you how these will works, right? Okay. And if I consider the first operator, which is and, okay, and is the first operator. Now let's see how and works. See here, and is an operator which uses the operator symbol as dot. Okay, dot is the operator for and which is simply means that it is like a multiplication. You can see here, this is multiplication. Okay, but you have to take the binary values only, either 0 or 1. Okay, if you ANDed, here you can see 0 is ANDed with the 0, that is 0 dot 0, the always result will be 0. Okay, 0 is ANDed with 1, that is 0 dot 1 equals to 0 again. That is same thing which we deal with the normal mathematics, right? Anything is multiplied by 0, you will get 0. Okay, that is how we are dealing here. 1 dot 0, that is 1 is ANDed with the 0, result is 0. Okay, and 1 is ANDed with 1. If both are 1, then the result will be 1. This is the working procedure of AND operator. Okay, here once again I will explain. And this operation is represented by a dot or by the absence of an operator. For example, here 0 dot 0, you may take the variable as x dot y. Here x is equals to 0 and y is equals to 0, then the result will be x dot y, correct? Or you can call result will be z. What is the result here? X is 0, y is 0 again, 0 dot 0, you will get z as 0. Like that, if you put the values of x and y, whatever the variations I have given here, you can put and you will get the result as a z. It means that the AND operator always gives the result as 1 only if both the input means here x and y input are high, or you can call both inputs are true, then only it will give the result as a true. You will get to know that how true false will be by that truth table. Okay, okay, fine. See, one bit logic or resembles binary addition. This is all about the or operator. Okay, and means it is in the form of multiplication. If we go for or, that is nothing but addition. Plus operator, here we use plus symbol to operator as a operator. Okay, again 4 combination have been taken here. 0 plus 0, that is 0, correct? 0 plus 1, result will be 1 only. 1 plus 0 also 1. 1 plus 1 is also 1. Here you don't think that 1 plus 1 equals to 2. No, that is not the case. Result is also only in the form of either 0 or 1. Result is always 0 or 1, not 2, 3, 4 and anything. Okay, here or represents that only when the both the inputs or both the values or both the variables are 0, at that time only it will be 0. Otherwise, in all the other cases, it will be 1 only. Okay, this is the operation of and or. Then how not works? Not is nothing but I'll write here not. How not works here? Not is operator for the not is prime, you can call like this, or bar. Say for example x means x equals to, if I write x prime you can call, or x bar also you can write x bar. Okay, if the x is 0, x prime is 1. If the x is 1, x prime or x bar is 0. Like that not get will work, right? Okay, you can see the truth table for this and, or, and not. You can see now here. Okay, okay. Hmm. Fine. This table is called as a truth table. Okay, these table for logic operators like and, or, not. Truth table, it is a tabular form that represents the relationship between the input variables of function and its output. Say here a and b represents the input, you can call these are the inputs, a and b are the inputs. Okay, f is the function which is obtained by the two variables a and b. Okay, okay. See, these are the combination which we taken. If only two variables are there, then four combination you will get. If three variables are there, then eight combination you will get. That is in the form of 2 to the power n. If two are there, 2 to the power 2 is nothing but four combination you will get. If variable are 3, then 2 to the power 3, what is the 8 combinations you will get, like that, right? As I told before, f equals to a dot b, in the sense a is ANDed with the b, 0 is ANDed with the 0, 0 you will get, 0 ANDed with 1, 0. Only when the input or output is 1, base the input are both 1. Or also you can write the truth table in the form of true or false. Okay, here true means 1, false means 0. Okay, 0 plus 0, that is 0. It means that false plus false dot false, you will get the result as false only, right? False dot true will get result as false. False ANDed with sorry, true ANDed with false, the result is false only. If both are true, then only result will be true. You can take true false, high low, correct, 0 and 1, like that. Okay, if you observe the truth table for OR gate, that is also very easy. 0 plus 0, or you can call that whenever the both the inputs are low or both the inputs are 0, then only the output will be 0. In other rest of the case, output will be 1. Okay, or whenever both the inputs are true, then only result will be true. Rest of the case, result will be false. That is the concept of binary logic here. If you see not gate or not uh, operator truth table here, if a is 0, a prime or a bar will be 1. If a is 1, a prime or a bar will be 0. Or you can call in the true false. If a is true, a prime is false. If a is false, a prime will be true. This is the truth table of this binary logic operators and, or, and not, right? Okay, as I told, this is a question here. A function depend on n variables. How many rows are there in the truth table of function f? That is, I explained here, 2 to the power n. Whatever may be the number of variables will be there, those number of combinations you will get. Combinations in the sense, these are the rows, right? One row, second row, third row, fourth row, like that. Okay, that is the answer also given here. 2 to the power n rows, since there are 2 to the power n possible binary patterns. Okay, okay, and let me introduce something about logic gates. The logic gates are represented like this. For each operator, like and, or, not, we have different logic operators. Logic symbols are there. Okay, those symbols are also called as a logic gates. Okay, and what are the logic gates and how it can be appear? You can see here, the first gate is known as AND gate, right? This is the symbol or circuit diagram you can call, or also it is a logic gate also, symbol for AND. This is also called as AND gate, right? This A and B represents input variables, okay, or you can call inputs simply. F means function, that is output, right? Here I have taken only two variable AND gate, two variable OR gate. NOT gate is obviously only, it has only one input, okay. Okay, this is two input one output, AND gate is there. You can have number of inputs also, okay, but here I have taken only for understanding, we have taken only two input one output AND gate, two input one output OR gate, like that. NOT gate is also there. F is equals to A dot B. Here F is G is equals to, you can call also F G whatever. F is equals to again A plus B, you can call, right? And H I have taken the, for the NOT gate, that is H equals to A prime. If the input is A, output will be A prime. If the input itself is A prime, output will be A, right? That is how the logical symbols can be represented for the three different operators AND, OR and NOT. I hope this is clear to you. If any question comes to your examination that write a symbol and truth table for AND gate, there you need to two variable AND gate they asked, then you need to write this symbol, okay, this symbol whatever is given here, this is symbol, and the truth table for this is here, it is given, right? This is the truth table for the AND gate, right? Similarly OR gate symbol is like this, truth table for that it is given here. The same way you have the NOT gate. NOT gate can be represented with this triangle with the bubble and only one input. Always NOT gate has only one input and one output. This is the concept of binary logic. I hope this is clear to you. Okay, thank you.